All right, slope-intercept form, graphing lines with slope and y-intercept. It is the basic way that we graph lines here in middle school math. So we talked about earlier, slope-intercept form is in the form of y equals mx plus b. If we know the slope, which is a constant rate of change, and if we know the y-intercept, the value of y when x is 0, we can graph. It's pretty simple. So here's what we talked about. Here's an example. Larry has $2 in his bank account, and he adds $3 each week. So you'll see I've highlighted some words, some key words. The red words that are highlighted in red help identify the constant rate of change each week is $3 each week. He has $2 to start with. So that equation would be, if we were to write that words into math, y equals 3x plus 2. That's the format of y equals mx plus b. The slope is 3, the constant rate of change, $3 each week. And the y-intercept, the starting value, when x is 0, is 2. So now we can graph it. We know those two things. We can graph. We don't need to make a table. We start at the y-intercept. We put a point at 0 and 2. That's how much money after 0 weeks. Then every week he gets $3. So I go to the y-intercept, I go over 1, and I go up 3. There's a point. After $1, he has the slope is, $5. After 1 week, I have $5. I make another point from here. I go over 1, I go up 3 more, and I have $8 after 3 weeks. That's an example of graphing an equation from slope-intercept form, knowing the slope and the y-intercept. Let's do 3 more. First example, Fred uses 3 gallons of gas per day. His gas tank holds 9 gallons. How could we graph that? Well, we want to know 2 things. We want to know the constant rate of change, and we want to know where we start, or basically when x is 0, what is y? And the numbers are pretty clear in there. The word per is always a huge clue as to the rate. If you are using 3 gallons of gas per day, that's a constant rate of change. So the slope is 3, and the gas tank holds 9 gallons. So you can visualize a gas tank holding 9 gallons, and it's using 3 gallons every day. That would be an equation of y equals minus 3x, because minus 3x is the rate, and 9 is the starting point. So the slope is minus 3, and the y-intercept is 9. So we go from the story to understanding the situation, to putting it into an equation, and to identifying, what the slope and y-intercept are. So now we can graph it, and we start from the y-intercept. We go to, when x is 0, we have 9 gallons in the gas tank, and every day he loses 3 gallons. So I go over 1 day, I go down 3. I go to second day, and I go down 3, and so on and so on. So there is your line. I can't actually get negative, but that is how that graph will work. Next example. It is 2 degrees on Mount Pilchuck. Brr, it's cold. And the temperature drops 2 degrees every 4 hours. There's that word in red again, every. That's going to be a constant rate of change. Every 4 hours, the temperature goes down by 2. Now we're starting at 2 degrees Celsius. This slope is a little bit tricky. I made this tricky. If it goes down 2 degrees over 4 hours, remember slope is rise over run. So how would that be? Well, that would be 1/2. That means it's going to go every hour, it goes down 1/2 of a degree. And this negative is going down, starting at 2 degrees. Now let me show you how that slope works on this one. The slope is negative 1/2. I know you're saying, how do I get 1/2 out of 4 and 2? The rise, 4 hours is the run. The rise is 2. We're going down 2 degrees. 2 over 4 is minus 1/2. So we will start our graph at 2 degrees because it's 2 degrees on Mount Pilchuck at 0 time. Every 4 hours, we'll do it this way. Every 4 hours, it goes down 2. So after 4 hours, 1, 2, 3, 4, it goes down 2 degrees. Now it's 0. And this is kind of a neat graph because it can go into the negative numbers. So after 4 more hours, 1, 2, 3, 4, it would go down 2 more degrees to -2. Now the slope of 1/2 comes in this. The slope of 1/2 is, we did this in 2-hour increments, 4-hour increments. We could make it in 2-hour increments and go down 1 degree. And you can see it's on the same line right there. So that's an example of y equals -1/2x plus 2. Same situation, we find the rate, the constant rate. We find out where it starts, and we graph from there. One more, Fred. Fred's in the elevator. Fred's in the elevator on the 2nd level of an underground parking garage. The elevator climbs at a rate, there's that red word again, climbs at a rate of 2 floors a second. So that sounds like the slope would be 2, and the starting point would be underground -2. So there's your equation. Y equals 2x, 2 is the slope, minus 2. 2x minus 2. So we can graph this the same way we have graphed the other ones. The slope is, the y-intercept is -2, so it's right on my picture. I don't know if that's going to work. We'll try that. So we move to -2 is where we start in the underground parking garage. And the elevator climbs at a rate of 2 floors every second. So after 1 second, it's at the ground floor at 0. After another second, it is up at the 2nd floor. So your line looks something like this. 1, 2, I don't have my glasses on. There we go. Goes over every second, the elevator goes up 2 floors. Over one, up 2, over 1, up 2, etc., etc. And there is your line right there. So that's a quick and dirty explanation of slope, y-intercept, the slope-intercept form, using slope, which is the constant rate of change, and the y-intercept, which can usually be interpreted as the starting point. Okay, so those are some examples. Review those, and this video clue is 4 of spades, by the way, 4 of spades. All right, thank you.